This is a production of Cornell University.
How do humans learn languages? Why do we learn them at all? In this Chats in the Stacks book talk series, originally presented at Mann Library on November 29, 2007, Dr. Barbara Lust from Cornell's Human Development Department presents highlights from her new book, Exploring Human Language Development from Birth. Please join us for a cross-disciplinary discussion of recent discoveries about child language acquisition that will touch on linguistics, developmental psychology, and cognitive science, and may help explain what makes those busy infants, toddlers, and preschoolers tick. Or rather, talk.
For inviting me. It's really an honor to be here in this wonderful library, wonderful and stunning not only because of the architecture, but because of the personnel and the infrastructure that you provide for us all over the university. So thank you so much for inviting me. What I thought I'd do today is start by introducing a few of the basic aspects of the field that we work in, which is the field of the study of language acquisition. Tell you a bit about the book, which Janet just mentioned that I just completed. Give you a couple of examples of discoveries from the study of child language so you can get a little feel of the kind of thing we look at and study. And then if there's time at the end, I'll kind of bring up some new developments of where new approaches that we're taking to go on into the future. So I think that to get started, the philosopher Dennett actually put the study of language and language acquisition very, very well, and its wonder and its mystery, I think, very well. He said, there's no step more uplifting, more explosive, more momentous in the history of mind design than the invention of language. When Homo sapiens became the beneficiary of this invention, this species stepped into a slingshot that has launched it far beyond all other earthly species and the power to look ahead and reflect. Now, it's clear that the human species' major transformation when language came about. Now, we don't know how and when language came about. I mean, some people estimate maybe 50,000 years ago. But we do know that each and every child in the normal situation that's born in any normal situation is going to acquire language, is going to acquire this wondrous, momentous change in the history of mind design. And they're going to do it in front of us. At the same time, we also know that it's going to be a tremendous intellectual feat for each and every child to accomplish. And some have said, as this linguist did, the language learning is doubtless going to be the greatest intellectual feat any of us is ever required to perform. Now, to get a bit of a sense for why it's such a momentous feat, because it's so unconscious in us, it happens so unconsciously that unless you're a linguist poring over what it means to know a language, it may not be immediately obvious why it is such an intellectual feat. But to get a sense of this, I mean, just think about a little Dr. Seuss, right? Whose little story of Tweedlebeetles goes like, what do you know about Tweedlebeetles? Well, when Tweedlebeetles fight, it's called a Tweedlebeetle battle, and when they battle in a puddle, it's a Tweedlebeetle puddle battle, and when Tweedlebeetles battle with puddles in a puddle, they call it a Tweedlebeetle puddle paddle battle, and it just goes on like that, right? Now, this is a simple, charming little story that, you know, you'd read to a very, very young child. But when you think about what it takes to be able to either comprehend or produce this little Dr. Seuss, very, very fine distinctions in sounds, right? Puddle, paddle, piddle, battle. Combinations of sounds to make different words, tweedle, beetle. Combination of words to make different sentences, new sentences never heard before, entirely creative. This is the capacity for language. And what we call recursion, right? The ability for a sentence to build out and build out and build out on the basis of itself. So a Tweedlebeetle battle, Tweedlebeetle puddle battle, Tweedlebeetle puddle battle, battle, and what infinitely possible, right? So the feat for the child, if you think about it kind of abstractly, the child has to master a sound, a level of representation that involves sounds, call it phonology, a level of representation that involves syntax, meaning putting sentences together, a level of representation having to do with semantics and meanings. I mean, what is a tweedle, beetle, puddle, battle, right? It's a new construction of meaning based on the words. And then the child has to relate all these multifaceted levels of language representation together and relate it to what they're thinking about and get new thoughts, right? New thoughts about different kinds of puddle battles, right? Or battle puddles or whatever. So the challenge, I mean, you can get a little bit of idea of the challenge that every child faces. And the challenge is even more remarkable when you realize, like as Janet said, people think there are like 67,000 languages in the world. Any one of those languages is equally accessible. It doesn't matter where, it doesn't matter what language. It's all going to happen. And also, as Janet kind of indicated, even more wonderful, we've begun to think, is the fact that a child not only can master this complex computation in one language, but you expose a child to 2 languages, 3 languages, they will acquire those. They will acquire multiple languages. So the intellectual feat of the child is truly enormous. Now, when you look at the field of language acquisition naturally is asking, how do we explain this? How does it happen in the child? How much is built in? How much is due to learning? When does it begin? Questions of that sort. And the field is characterized by quite distinct approaches. It's characterized by approaches of scholars who take the more rationalist position, like Chomsky in his position here, for example, at MIT, who says we have to determine how it is that the child comes to master all these rules and that constitute the mature system, that how they come to know language. And the rationalist, the Chomsky position is there must be something biological program, mechanisms, some sort must be given to us through the brain, must be given to the human species in the brain. There must be what he called a language faculty, a faculty of mind and brain that has something to do with language. And as you probably know, he developed a theory of what that language faculty would look like, and he called it a universal grammar, claiming that there must be a set of innate mechanisms, a biological matrix. It provides a framework for the child for the acquisition of language. But just as going way back to the debates between Locke and Descartes, these tensions between scholars looking at that rationalist perspective and scholars looking at a learning perspective. Others in the field are arguing, as complex as this task looks, language acquisition, really, you don't need to postulate a language faculty. Maybe you don't need to postulate biological programming. Maybe children actually, after all, do imitatively learn. They just use general cognitive principles. You don't need specifically linguistic principles, right? So these are kind of strong debates in the field, different people studying language acquisition, making very different arguments about how it works. Well, our question was, well, on our question for our life's work and our lab's work in language acquisition is, how can one make this scientifically tractable? How can we study it, right? How can you actually get evidence? And it's a very difficult field to work in because, of course, it's tacit knowledge. It's unconscious. We really know, I mean, we understand, we speak language, but unless we're linguists, we don't make that knowledge conscious of exactly what's going on in our mind. And there's nothing tangible. Like if you look at a young child, you don't have literacy, for example, you have speech and hearing and understanding, and what is that? That's sound waves in the air that are passing back and forth between people. How do you study that, right? How do you get the data, the scientific data, to make this whole field scientifically tractable? And the whole challenge is made even more challenging when you realize that it actually is, within the first 3 years of life, that this transformation of knowledge happens. Generally, before the child is 3, they have mastered, generally, under normal situations, one language or the other. 3 years, very short, less than an undergraduate education at Cornell, right? And all of this transformation, this intellectual feat, is going to happen in that child. So what we did was, when you ask, like, how can you study it, we felt like, okay, we'll take this on, but you have to realize that when you study how this happens, it's going to have to be an interdisciplinary field. It's going to have to involve linguistics, so you understand what's being acquired, what language is. It's going to have to involve developmental psychology, so you know something about the developing child. And if any of you know infants between birth and 3 years of age, you know so much is going on developmentally there in addition to language, right? You're going to need experimental psychology if you're going to do a good experimental scientific method, and you're going to integrate some neuroscience, because it's definitely the brain, we have to say, is definitely involved here. It's a paradigm case of what you call cognitive science, right? Study of language acquisition, an interdisciplinary field. Well, what I did in the book was realize that this is a field, it's exploding with research. It's exploding, and over the past decades, it's been exploding with different research studies from all these different points of view on all these levels of representation, like how the child acquires the phonology, the syntax, the semantics. And so we thought, we'll call that research, and we'll bring it together, and we'll assess it, we'll look at it, and we won't just limit ourselves to one aspect, like phonology or syntax or semantics. We'll look at how they're all developing at once. And we'll try to kind of assess the state of the art with regard to the leading questions, and we'll take an interdisciplinary approach. So that's basically what the book tries to do. And I think that at this point, what we thought might help would be to take 2 concrete examples of the kind of research that's reviewed in the book, but research that's occurring in the field, research that's telling us something about really fundamental aspects of the child's language acquisition, and just give you a couple of concrete examples. Now, the first example we want to give you is one that involves the child's acquisition of syntax and semantics, so the computation for putting sentences together and having them achieve new meaning. And the second example we'll give is an example of research from the child's learning of words. You'd think the learning of words was very simple, but it turns out that it's not. So let's look at the syntax and semantics example first. And I want to choose for that one particular experimental study. It was led by Claire Foley, who was a graduate student at the time at Cornell when she first developed the study and is now teaching at Boston College. The study has the term sloppy identity, but I'll explain what that means. And the study has to do with the syntax involved in little sentences that look extremely simple, but are not. So Ernie touches the ground and Big Bird does too, right? Now, we know immediately, tacitly, but immediately what Big Bird does, right? We know that Ernie touches the ground. We know Big Bird does too, right? Even though the sentence doesn't tell us, right? So the mind somehow does a computation. It looks at the first clause, and if you were a linguist, you'd call it reconstruction. It goes in, it takes bits of the first clause and adds it to the second clause. Automatically, right? So we wondered, it's kind of an interesting area to look at in child language acquisition. In the case where there's nothing there on the surface, what does the child mind do? Maybe this would be an area where we could start to capture what computation the child mind is capable of and when it's capable of it, right? But then it gets a bit more complicated. So a similar sentence looks similar. Oscar bites his banana and Bert does too, right? It's a simple sentence. If we heard that sentence, we wouldn't think, my heavens, this is so complex, I'm going to have to work at interpreting it, right? But what does the sentence mean, right? Oscar bites his banana and Bert does too. You kind of know, you pick up the first clause and you get that bite, so you know Bert bites something. But what does it mean? What do they each bite, right? What does Oscar bite? What does Bert bite? What comes to people's mind, I wonder, as to the meaning of that sentence? Anybody want to suggest what they think it means?
Well, my first thought, the bird bit the banana that Bert had, but then I looked at it and I thought, well, maybe bit Oscar's banana. So.
Right, both are possible, right. It's a paradigm case of ambiguity, right? And even there are a couple of other possibilities there. If Ernie's out there and you're talking about his bananas lying out there, you can say Oscar bit his banana and Bert did too and have it refer to Ernie, right? And there are actually 4 possible readings that are possible given the right context that you might get there. Multiply ambiguous sentence, right? Even though it looks quite simple on the surface. And what else interested us was there are also a whole set of impossible interpretations. If you can have all kinds of people's bananas out in the environment, and you cannot interpret that sentence to mean Oscar bites Oscars and Bert bites Ernie's, right? You can't interpret it to mean Oscar bites Bert's and Bert bites Oscar. There's a whole set of impossible interpretations, no matter how many bananas are out there, right? So we thought, this is very interesting. We wonder, is the child going to be capable, and at what age, of dealing with these sentences where there's actually nothing there, dealing with sentences where it's multiply ambiguous, dealing with sentences where, given the real world, all these different interpretations are possible, but your grammar tells you cannot, no matter what, interpret them. So the idea would be, what would a young child do? And Claire Foley and her team went out to study this. And they also noticed, actually, that first interpretation that you gave, where they each do their own, they said, well, what you have to realize is this is the most complex interpretation, because you kind of have to say there's a variable in there. They each do their own. It doesn't matter who it is, right? When you reconstruct from the first clause into the second, there's no specific banana that you're picking up to put in that second clause, right? What you're picking up is the idea that they could each do their own. So you think, looks like the representation in your mind involves some kind of variable here. The lab team was also wondering, with children actually, maybe they get one reading. You call, where they each do one single object, you call that a strict reading, right? And that's a little easier to see. There's one object, you carry it over. Maybe the child would get that first, and maybe the child would have trouble with this reading because it's so complex, right? Those were all possibilities. This reading has a very bad name. It's called a sloppy interpretation. It's not sloppy at all, right? But it's called a sloppy. The other kinds of readings where they each do one single object, they do the same object, it's called various kinds of strict. Well, the lab team went out very bravely and tried to set up an experimental design where you could test very young children on how they would interpret sentences like this and whether they would get all interpretations. And we'll show you a real example. But essentially, they put the child in front of 3 plates, Bert's, Oscar's, and Fuzzy Bear's, for example, which had several objects that they owned on them. They had little pictures of whose plate it was in front of the child and in front of the plate, so they would remember. And then they would give them these little sentences and see whose banana they thought they bit, or whatever, right? So let's give you an example.
Oscar bites his banana, and Bert does too.
Bert bites his banana? Bert bites his banana? Bert bites his banana?
This child is just 3, just turned 3.
Bert bites his banana? Does he look like banana peels? How are we gonna get this banana?
Well, we don't have to peel the banana. We could just pretend he's not peeling. Okay? Just pretend. He bites into the peel. Good.
Oh, Oscar bites himself.
So you see, this child had just had a birthday, just turned 3, and they're giving a sloppy interpretation. They're doing child things like saying, "Why did you silly experimenters give us bananas that you can't really eat?" and things like that. But at the same time, they're doing this complex computation for this interpretation of the sentence, right? And you notice how long it took. You mastered giving the child enough time to do the second part first and then the first part, and didn't move in and try to clue them or anything, right? But it wasn't only this interpretation that was found in this study. We'll give you another example to show that.
Ozzy Bear rolls his orange, and Bert does too. Is that going to work? Oh, boy.
Okay, so there's a strict reading. They do the other interpretation, right? And we also tested children. We tested whole groups of children on this, and even tested some younger children. And interestingly enough, we'll go into the precise results here because I just want to draw some general conclusions about what this showed us. But the sloppy interpretation, the complex bound variable one, actually was the preferred one, although children show you that they can get both, and they know that sentence is ambiguous, right? So this kind of research, a child just turned 3, you can even get it with 2-year-olds. It was quite remarkable. I mean, a child that young, I said that basically by the age of 3, a child had acquired one language or another, but now you see the complex computation that's actually involved there by the age of 3. So complex syntactic and semantic knowledge, dealing with ambiguity, one form to one meaning no, one form to many meanings, right? And the child didn't make all those impossible didn't make all these impossible interpretations, which it's your grammar, it's your language faculty that's telling you that you can't do those, right? So one result, and it's one result which there's other research in the book that deals with complex computation, evidence for that by the time the child is 3, and we're beginning with research to begin to try to make precise what that computation looks like. Also, we did go out to other languages. We did some with Yu-Chin Chen, who also had been a previous graduate student here and is now teaching at San Bernardino. We did some kind of matched comparative research in Taiwan on Chinese, and you got similar results in Chinese. So strengthening the results that there's something there. There's something in the language faculty. But let's look at another example, and another type of examples. I mean, that example was kind of like how much is acquired and is there by the age of 3. But getting to the age of 3, actually 3 years short for us, but very long in a child's life, a lot of development going on during that time. So a lot of the research reviewed in the book has to do with the development of knowledge over those first few years in the areas where it occurs. Now, one of the areas where it occurs is words, right? Word learning. And it takes time. I will show you some examples. It doesn't happen overnight, and yet it also seems to happen quite quickly. Like people who study word learning often say, well, the child must be learning like 6 to 8 words a day when the child starts the first words, and then up to 45 a day. And the reason they say that is when they kind of look out how the number of words a child seems to know changes over time. You see like how it going from 16 months, it's not even 2 years, 29 words, but 103 words by 20 months. And by the time we're us, 50,000 to 300,000, I mean, we vary a lot, and we're probably still at work acquiring new words, right? But again, the process is a complex one. It's a complex task for the child, and people are studying how this happens as well. And to make that point, we want to show you another example, another kind of example. This will be a younger child now, a child not quite 2, first of all. Acquiring their first words, simple words, like, right? We studied them doing apple or doggy or whatever. And demonstrating what's something very, very common, which is called overextension, the overextension phenomenon. And we just want to give you an example of what that phenomenon is.
Apple. Apple.
Do the fruits and vegetables.
Yeah. Apple.
Where's the pumpkin?
Apple.
Where's the pumpkin?
Apple. Apple.
Where's the pumpkin, Brian?
Apple. 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 Apple.
Show Mommy the pumpkin. Mommy wants the pumpkin. Yeah, show Mommy. Mommy couldn't see the pumpkin. Show Mommy the pumpkin.
Apple. Apple.
Mommy wants the pumpkin. Which one's the pumpkin?
Apple. 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 Apple.
Hey, Brian, show me the pumpkin. Where's the pumpkin? Where's the pumpkin?
Apple. Apple. Apple.
That's a lemon.
Apple. 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 Apple.
Is that an apple, honey? Is that a lemon?
Apple.
You sure it's not a lemon? Where's the pumpkin? Did we lose the pumpkin? Where did it go?
Oh. Apple. 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 Apple.
Really?
Apple. Banana.
What's this?
Apple.
What's that?
Apple.
What do you have?
No.
What is that?
Apple.
No, what is that?
Banana.
What's this?
Apple.
What's that?
Banana.
All right.
So you see, it's not, acquiring a word, it is not an instantaneous process. And it's not like learning a little label to a little object, right? It goes through the mind and the child's mind. And it takes time. And you can see when the child's kind of getting it worked out for banana, you know, but apple, pumpkin, whatever, it's taking time. Now, it changes, right? The child becomes like us. We'll show you an example of that at the child when the child was 4 years old.
Because it's orange.
What's that mean?
Because it means it's middle.
Oh, it's not a pumpkin? It's not an apple? I think it's an apple.
No, it's a pumpkin.
It's yellow.
Well, that's the guts.
Oh.
What did you say, Brian?
I say guts.
Oh, that's the guts are yellow, you mean?
Oh, that's inside. It's not an apple?
Nope.
Oh.
How can you tell?
Because it's a pumpkin. And there's orange on it. Yeah, and the orange and green are washing away.
Ah.
They're washing away?
Yeah.
What do you mean washing? Oh.
Look, they're drying away.
Oh, that's because it's spotted.
But if they go away, maybe it's not a pumpkin anymore.
Yeah, maybe it'll turn into an apple.
Brian, Grandpa thinks it's an apple. He's sure it's an apple.
No, it's a pumpkin. It's pumpkin. pumpkins are for Halloween.
And what about
I'm going to
apples?
cut this for Halloween.
Well, what about apples? Apples are for Halloween because you bob for apples on Halloween.
No, they're called pumpkins.
Oh, I see.
Like jack-o'-lanterns or pumpkins.
Uh-huh.
They cut and they have lights and candles in them
I see, yeah.
at night.
You can't make a jack-o'-lantern out of an apple?
No, you make them out of a pumpkin.
Oh, I see.
And pumpkins are kind of fruit.
Oh, okay. It's a pumpkin.
No, this is a pumpkin.
What's this?
That's an apple.
How do you know it's an apple?
Because it is. It's red.
Oh, they're green apples?
Yes, some are green.
Okay, then how do you know they're apples?
And some are yellow.
And how can you tell they're apples?
Because they are.
Can you have an orange apple?
No, this is called a pumpkin.
So you see, somehow the child, it changes. The child's quite sure now that we are crazy for even thinking that a pumpkin could be called an apple. And, you know, the mystery is, why is the child so sure now? What happened in between? You know, what happened from the beginning when the child was so convinced of its theory? And now, I mean, what made the child change? What made the child become like us? And you can see the child trying to give all these arguments, like it's colored or whatever, but none of them would really work to give a meaning, and yet the child knows as we do, right? So here's a different kind of example, but a kind of example that targets developmental change, right, when you study this kind of thing. And I mean, you get a sense of what development is consisting of here. I mean, first of all, the child is very creative. I mean, not all children are going to call pumpkins apples, right? It's thought that, you know, between the child at 1 and the child at 2.5, maybe 1/3 of their early vocabulary involves this overextension, the very basic property of word learning. We don't know exactly why, and all children are doing it differently. Right? Some children call all cars buses, all buses cars, or whatever. Everything's red, everything's yellow. I mean, the child is creative. They're abstract, right? I mean, it has to be abstract. Computation, the child is not just taking one single apple and saying that's apple, right? The child has some kind of categorization going on. The child's not copying. You know, you can tell that child it's a lemon 1,000,000 times. Right? And you can tell the child it's a pumpkin 1,000,000 times, but you probably better not try, right? Because the child isn't copying, the child has their theory, and unless that theory changes, it's an apple, right? But, I mean, this is contributing now when you start looking at developmental change, at real mysteries. Some form of experience is necessary here, right, to make the child change, something that the child experiences telling, but something about the child's experience is happening. So studying development must involve all these factors, and it's quite complex. So I just maybe a few summary and conclusions here of the type of work that's happening in language acquisition now. In the book, as I mentioned, I tried to summarize a lot of the major discoveries that are happening in the research on child language. And one of the major aspects of that result of the study of development was that so much is happening before the child even speaks their first word. During that first 12 months, you're not seeing the child really produce words, they're not speaking in sentences. But there are tremendous changes going on in the child's mind. So very, very fine distinction of sounds of all the world's languages. But by 12 months of age, the child's honed it down to the sounds of their own language. 7 to 8 months, you read stories to children, come back 2 weeks later, they'll remember words from those stories even though they won't understand them, even though they're complex words like Pythagoras or whatever. So the child is working stream continually during those first 12 months. And when you look at that research, it becomes so much happening during that first 12 months that it's no wonder that at about 12 months of age, the child shoots off into this production of first words and then very early sentences. then thereafter will follow a whole process of development as well. So the book I kind of divided up between research before the first word and then research, after the first word. Try to put a whole developmental course together. By the age of 3, as I said, it does seem as though a full system, not everything, but a basic grammar for a language is in. And another basic result, which I thought was, after I did this, was one of the things that was impressing me the most, was you can see that during development, from birth, the child is working on all the levels at once. They're acquiring the sentence structure, the sound structure, the words. That's all going on at once, which makes the developmental, I think, even more amazing. It seems like it would be enough to be working on one of those at a time. So what do we conclude? And I'll just kind of share with you what I take to be the major conclusions when you put a lot of this research together. If you look at that early complex knowledge, like in the little child in the sloppy identity study, I don't see how you can explain that early complex syntactic and semantic knowledge without acknowledging that there must be some biological programming in a language faculty to do that, right? When you look at those kinds of results. And yet, we know when you look at the other parts of development that the child is using experience. There's not just an innate unfolding of what's biologically programmed here. It couldn't be, because the child's acquiring either English or Japanese or Tulu or whatever. The child acquiring pumpkin and apple is acquiring specifically English words. And it's got to be using experience from birth to build what we think is that they have to use that experience from birth, considered by what's biologically programmed in them, to build a theory of how the language works, a theory of Tulu, a theory of Japanese, a theory of whatever the language is. So we'd say that there's learning and there's experience. This is kind of attempting, I guess, to put the two approaches together, but to say that you need both of those approaches that we talked about. You need some of the rationalist and you need some of the empiricist. You can't throw one out. There's some kind of learning. It's a different kind of learning, though. It's not a stimulus response like a pigeon in a pigeon box, or it's not copying or memorizing. It's learning in a sense of using experience, but the child creates a theory of how the language works, and doing so in a way guided linguistically. And so I guess what this leads to, in the book I've kind of put those conclusions together and attempted to kind of design a new approach to a theory of language acquisition, or a theory of development, one which we call grammatical mapping. And it's one which just says, let's look at what's biologically programmed, let's look at how that constrains and guides the child in mapping from whatever it's born with in its brain and mind to that specific language, all that data, all that complex variable data, and helps them put that specific language together to build a theory of that language. That's the major intellectual feat. And I guess, as Janet kind of intimated, or more than intimated, explicated, having put the book together and having put, thousands of results of research studies together and gotten all these really interesting results in all these various dimensions, you still feel that it's an essential mystery as to how the child did it, right? I mean, even if you say the child understood all that complex computation and Ernie did two sentences, there's some biological programming. I mean, what was that programming and how did it work and how did the child use it? I mean, how did the child ever figure that out? Why did the child ever change from it's not an apple? What made the child change? It's not direct telling them what went on in the child's mind. This essentially is it essentially leaves the mystery of language acquisition with us, and it's what drives us to continue to work in the field. And again, it's the child who holds the answer to that mystery. So, it's this that drives us to continue to study the child in language acquisition. So, I actually don't know what time it is, and I could introduce the BCLA a little bit, but should I stop or should I give a few? Okay, I just wanted to bring up a couple of last points about where we're going in the future, because I think there's some exciting developments happening here at Cornell in terms of getting the field to have more power in studying this mystery. And our attempt is to build what we call a virtual center for language acquisition, which really means that you don't actually work alone in your own lab, but you're able, using the internet and the digital age, to have labs across different places in different countries, different institutions, work together and collaborate together to share data and materials. And we're actually building that in a partnership with Mann Library, because the library is, of course, the professional on how lots of data and materials can be stored and accessed and disseminated. So building a virtual center like this, it partially, I think it's being centered at Cornell, although there are several institutions across the country involved in it, including MIT, for example. But why is it centered at Cornell? And I think it's centered at Cornell partially because of the strength of the library we have here, and because our library, Mann Library, in fact, is in the vanguard of this new kind of explosion into the digital age. So what we're trying is to take data from across languages and across countries. There are probably like 20 languages of data in the Cornell Language Acquisition Lab, and once you put a virtual center together, that data comes in from all countries and all institutions. So you can see it's a massive amount of data, but this, for example, is like data collected in Sri Lanka years ago that we would be pulling together and databasing, building a tool for representing that data so it can be shared. So the metadata can be shared and stored, and so that people at different institutions can be calibrated in how they're working to share data. You can, if you have the data and you've got it stored, you can do all kinds of analysis, including the phonological or phonetic analyses on it. You can develop on and off-site collaboration. So, for example, this is Claire Foley, who developed the experiment we talked about at Boston College, participating in a teleconference. And on the left, you have a child in our nursery school being tested on Claire's study by an undergraduate, at the time, Lauren Muskowitz, getting data, analyzing the data from the study, and being able to collaborate with Claire on its interpretation, and also building materials for teaching our students how you can actually do scientific research in this area. So through several faculty innovation and teaching grants, we've been able to try to merge research and education by building these materials and making them available to students so they can participate with us and with other places. So I'll put this up. There's several, many people, including all the people in the Cornell Language Acquisition Lab, who are making, I think, a wonderful research paradigm work here at Cornell, in the Cornell Language Acquisition Lab, but many others, including Jim, who put the keynote presentation together. And I'll put this up too. But we're indebted to several grants, as Janet mentioned, that helped us, and a recent grant from the Einaudi Center that's helping us build the virtual center so that it can be activated internationally. It can start being activated internationally. So that was really all I had.
Well, I think we should thank Barbara and then ask her if she has some time for questions.
This has been a production of Cornell University. On the web at cornell.edu.